some students, I don't know what will happen for you in exam. Sir, the G is not given. Why you should give G now? Here, look at this. So it's like you are working on a table now. How mg will act perpendicular to plane of the paper. Then you know to mention the G. If the if the loop lies in vertical plane, G will come into picture. If the loop lies in horizontal plane, the G, the effect of it will not come into picture. You have to be very careful about the orientation of this circuit. Vertical rails, then the effect of weight will come. Horizontal rails, effect of weight will not come. Of course, any torques, something they are asking, then you have to take effect of weight also. There's a uniform magnetic field is there, long rails are there, and the ring is moved with a constant speed V0. Find the external force acting on the ring. Now go back to the motional EMF. We said no, effective EMF, effective length, the idea of effective length, so the same thing here now. So break up this ring into two parts. Break up this ring into two parts. Let me take this ring. I'm going to move this ring here. So the ring here, it will have call 1, 2, 3, and 4. And I'm moving with a constant speed V0. Let the radius of the ring be A. B bar is everywhere into the plane and it's a uniform. What should be the external force? I should apply it. So shall we say 1, 2, 3 is one ring, one rod, and 1, 4, 3 is also one rod. And moving rod, what you do? You can replace with a cell. So the equivalent circuit. Just stick on to the basics, or don't bother anything big. Because even the final exam, the questions that are coming will be on just simple applications. Now I'm going to replace this ring by equivalent cell, because we are more comfortable with replacing the moving rod with a cell. How to replace this with a cell? 1, 2, 3 will become one cell. And it's having resistance called R, this EMF. Similarly, so what is this E123? What is this E143? And both are moving with a constant velocity V. Now, will there be any current I? Yes, a current I will flow like this. Let this be I. Then the resultant current here will be 2I. Or if you want to make it I by 2, you can do that one. So a BIL force will act here. Actually, I show at the midpoint. I don't have enough space, so I'm showing somewhere BIL. Where the BIL force should act at center of this one. Okay, this is about the BIL. Now, some external force should be applied, no? Otherwise, the constant speed cannot be maintained. That external force is what? On the rod like this. So what should be the external force? 2 BIL. So what should be the external force? How much I should apply? 2 BIL. Straight away, let's get into the problem. F external equal to 2 BIL. What about I? E123 by R or E143 by R. Well, same current will flow in both the parts of the ring. Yes, the same current will flow. How to get the magnitude of E12? Effective length BV2A. What is the effective length from 1 to 3? So where shall I write pi A or 2A? Look at this part. Should be pi A or 2A. It should be 2A, no? The effective length, not pi A. Substituting that, we'll get the external force that should be applied. So different shaped now. Frames, rod, anything will come into picture. You must, and see, resistance, don't go for what is R? I think we have to define R also. What is R? resistance per unit length, no, lambda into pi a only. What do you suggest, or shall I go for 2a? For the resistance, you should not go for effective length, no? So therefore, now the required answer will be f external equal to 2 times b. What is I? I will be bv by 2a, and this length also here. Here also I wrote L, no, it should be 2a, that one. Huh? What is value of I? bv by 2a, lambda is lambda by pi a into this 2a. This is what I. What about power? That external force into the speed of the rod will be the power generated by extrusion. Where it will go? Taken by the ring. So what is here ring? It is acting like a source of EMF, and also it is dissipating, no? So that resistance of the ring bottom will become internal resistance of a source. So therefore in the motional EMF, the moving rod or the moving structure, if it is having any resistance, that will become internal EMF, internal resistance of that particular EMF or that particular cell. So what should be suggestible? What type of ring I should move here? Ring with high resistance or ring with low resistance? To trouble you, questions will be of this kind. See, what is the main purpose of this? I want source of EMF, and the ring is now source of EMF. This ring is a source of EMF. And you go for current density. When you have a cell, so what do you expect internal resistance? Should be high or low? Should be as low as possible. No? So practically what should be the resistance of the ring preferred? As low as possible. They may test with very generalized application like this. So any arbitrary shape, so some trapezoidal frame, triangular frame can be moved here. So you should get ready for different types of structures here. So here I'll be moving like this. So I'll move a triangular frame. Then so in books we have routine problems where we have very routine problems. Let it be there, no problem. So I can move any structure here, no? Of course, the resistance of this very difficult to find out. Huh? Here we can find out the resistance. If I give total resistance R, I think it's okay, well and good. Here we can find out. Here very difficult. Huh? So let me make R is the total resistance. So this is a B bar. So then what is the external force I should apply to move this particular loops? There's a generalized thinking what you should generate. Huh?